Today we're going to be looking at dividing rational expressions. And so when we divide, remember that you keep the first fraction and flip the second one and multiply. So we are going to be looking at, so like if I had 3/4 divided by 2/5, I would do 3/4 times 5 seconds. And nothing could reduce. We couldn't cancel in the diagonals, and we can't reduce in up and down. So you multiply and you get 15/8. So we're going to do the same idea, but with the rational expression. And so what's the quotient? That's another way of saying divide these. I have 3x divided by 4y divided by 6x over 5z. So step one is to rewrite this in factored form if it needs to be in factored form. Well, this one doesn't need to be factored because there's not, it's just monomials. So you're going to keep the first fraction, change to multiplication, and flip your second fraction. And now we're going to look and see what can cancel. So the 3 and the 6 can both be divisible by 3, so that's going to be a 1 and a 2. The x's can both be canceled, leaving a 1 and a 1. The 5, there's nothing that can cancel with the 5, and there's nothing that can cancel with the z. There's nothing that can cancel with the 4, and there's nothing that can cancel with the y. So we're going to go ahead and multiply. And so this is just a 1. 1 times 5z gives me 5z. 4y times 2 gives me 8y. So that's what it's equal to. Now, where it gets a little bit more complicated is in our restrictions. In your restrictions, you have to consider anything that make it a 0 here in that denominator. Plus, you can't divide by a 0, so anything that make this fraction 0. So our restrictions are going to be that x can't equal 0, because that's in the numerator on the second fraction. Y can't equal 0, because it's the denominator of the first fraction. And that z can't equal 0, because it's the denominator of that second fraction. So it doesn't matter where it's located in the second fraction, it has to be no zeros there. But in this first fraction, you just can't have a 0 in the denominator. So the only spot that can have a 0 is here. In which in this case it wouldn't be because the x is in other spots. So the restrictions are x can't equal 0, y can't equal 0, and z can't equal 0. And the quotient is 5z divided by 8y. So let's go ahead and look at the quotient of this. And we have 7x plus 14 divided by x minus 1. And if you look here, this x minus 1 is already there's nothing to factor out of it. The 7x plus 14, there is some things we need to factor out, so we'll take care of those here in a second. There isn't a squared term, so you're not going to need the box. And then 7x squared minus 28. And you'll notice that there is a 7 that's a factor out of, is able to be factored out of both pieces, so we're going to factor out GCF. And then factor using the box. And the same thing with the denominator. We need to first factor the 5 out of both pieces, and then we'll be able to factor the denominator. So let's go ahead and do that piece first. So 7x plus 14, there was something we could factor out of both pieces there. We could factor out that 7. So 7x divided by 7 is x. 14 divided by 7 is 2. X minus 1 divided by, on this next fraction, we have the 7 that can factor out of both pieces. 7x squared divided by 7 is x squared. Minus 28 divided by 7 is 4. And then we have 5x squared and 5. And so we can factor out a 5 from both pieces, giving us x squared minus 1. Now, we need to take and look at our quadratic terms. And so this is the difference of squares, so we're going to go ahead and factor that using the box. And so we have our x squared here, our -4 here. And so that's -4x squared. What things will multiply to give me -4x squared that will add to give me 0x, because that middle term is gone. And so that would be the -2x and +2x. And so we fill those in. And so looking at that first column, I can factor an x out of both pieces. Second column, I can factor a 2 out of both pieces. First row, I can factor an x out of both pieces. Second row, a -2 out of both pieces. Now, we're going to look at the next thing that we can factor. And let me change colors on this real quick. And we have factoring that denominator here, x squared minus 1. So x squared -1. So that's going to be -x squared. What can multiply to give me -x squared that will add to give me 0x? That's going to be a -x and a +x. And so that first column, an x can be factored out. Second column, a 1. First row, an x. Second row, a -1 because the closest sign was negative. And so I'm going to rewrite this with what I have. And so 7 times x plus 2 divided by x minus 1. And I haven't changed this to multiplication yet because I haven't got it all factored. If you want to at any point, you can. I just usually wait till I get it factored first. And then we have 5. And that's just filling in my factors that we created over here on the side. So now let's go ahead and divide. So that means we need to change to multiplication and flip this fraction. So we have 7x minus x plus 2 divided by the quantity of x minus 1. We're going to change to multiplication, and we're going to flip the second fraction over. So it's going to become 5x plus 1, x minus 1, and then 7x plus 2, x minus 2. And so we're looking to see what can cancel. And so this x minus 2, or excuse me, x plus 2 can cancel in both those two places, as well as my 7 can cancel in both places. Another thing that can cancel is this x minus 1. So that leaves me 5, oops, that's the wrong color. 5 times x plus 1, all divided by x minus 2. And you can multiply that out or you can leave it distributed. You don't have to go any further than this. And so let's find our restrictions. And so anything that is the denominator of the first fraction or anywhere in the second fraction, so let's go ahead and go over here to this one that was factored, are the places I need to worry about. So that denominator of the first one was x minus 1 can't equal 0. On the second fraction, I don't have to worry about the 7, but I do need to worry about the x plus 2. It can't equal 0. X minus 2 can't equal 0. Oops. And the x plus 1 can't equal 0. That's the denominator of that second fraction. As well as the x minus 1 can't equal 0. Well, we already have that one listed, so I don't need to list it again. And so we have On the first one, it's going to be x can't be 1. On the second one, x can't be at -2. The third one is x can't equal +2. And on the fourth one, x can't equal -1. So the 4 places that we can't have x values, the 4 restrictions we have are these. So this is true when we do not have the x equal to one of those 3 values. And this is the reduced quotient. Let's look at this question number 3. We want to find out what the quotient is of 2 minus x divided by x squared plus 2x plus 1 divided by the quotient of x squared plus 3x minus 10 divided by x squared minus 1. And so I went ahead and didn't show the video of how to factor those binomials, but let's look at how you factor this numerator. And why I need to factor it is it's not in the same order. We don't have it to where the x is listed first. And since there's a negative sign there, I'm going to end up factoring out a -1, which is going to switch the order with a subtraction sign. If it was addition, I could just rewrite it. But since it's subtraction, I need to factor out a -1 to be able to do that. And so we are going to be looking to see what we need to do next. Right now, I've got it at the factored state. So after the factored state, I need to rewrite it where my first fraction doesn't change. My second fraction flips. And so I'm changing to multiplication, and I'm going to reciprocate the second fraction. So I have x minus 1, x plus 1 divided by x minus 2 times x plus 5. And so now I'm going to look and see what can cancel. And so the first thing I see that can cancel is I have an x plus 1 and an x plus 1. The next thing I'm going to see that can cancel is this x minus 2 and x minus 2. Now, what I have left is I have an x minus 1, and there isn't one in the denominator. I have a -1, there isn't one in the denominator. I have x plus 5, or x plus 1 and x plus 5, and there's not one in the numerator for each of those things. So now we're going to combine them. That -1 is just going to come in front, and it's going to be written as a negative sign. What was left of my numerator, there was just one term now, so I am going to just write it without the parentheses. In the denominator, I have the x plus 1 times the x plus 5. And then we're going to go through our restrictions. So again, the restrictions come from the first denominator and anything in the second fraction. And so the only reason it's all of that this time is because we are dividing. If it was multiplication, it would just be the denominators. So I have x plus 1, and that's used several times, so I'm only going to list it once. I have x minus 2 can't equal 0, x plus 5 can't equal 0, and x minus 1 can't equal 0. And so that gives me x is equal to -1, x is equal to 2, or x can't equal -1, x can't equal 2, and x can't equal -5. And so those are the things that I cannot plug in for x. This fraction is true as long as these values are not used. Now, I want you to work on number 4 on your own. So first step is to factor. Then you need to reciprocate the second fraction and cancel. Here's the work to check, and don't forget that we had to get all, for the restrictions, we had to pull it all of these spots will be involved with the restrictions.